Nope. Working okay this morning, actually. Right. B6A part 1. So you have children here. The youngest is 7, 8, 9, 7, 7, 8, 9, 11, 13, 15. Is that all of them? 1, 2, 3, 4, 5, 6, 7.
Yes.
So the median is equal to 9. The mode, what's the mode? Nope, 7. And the mean? 7 plus 7 plus 8 plus 9 plus 11 plus 13 plus 15 divided by 7. The mean is 10. Standard deviation. So for the standard deviation, I'll calculate the mean age squared, so that's 100. But I'll need to calculate this one as well. So I need to square all of these. 49, 49, 64, 81, 121. What's 13 squared? 169, isn't it? 169, 225. What do you mean, why do I square it? The formula?
This formula. The first one is
so sigma squared will equal this one minus this one. You remember this, KJ? Or were you asleep, maybe? 49 plus 49 plus 69 plus 81 plus 121 plus 169 plus 225 divided by 7. So that's 109. So then sigma will equal 3. Part 3 is interesting. Yeah. I don't necessarily think you'll get a question like this, but it's not really a maths question, it's more just a logical question. In 3 years' time, what would be the average age of these children? Well, what's their mean average now? 10. And in 3 years' time, what would be their mean average? Well, they'll all be exactly 3 years older, so their average will increase by exactly 3 as well. 13. The standard deviation will be what, though?
3.
Yeah, very good. The standard deviation doesn't change because they all age at the same rate. So the spread of the data doesn't change because it's almost like a group of people moving together. They don't become more or less spread out. So it's only 1 mark, so that's fine. Okay, let's have a look at B now. Can I scroll down? So I'm thinking it might be easier if I use a program here. So this is a frequency table. Now here he asked for the frequency densities, but I'm going to change this one a little bit to match it more with what we're doing with histograms. So I'm changing this a little bit to make it more like what we do. So do you remember how, well, let me write down the times. You have the lower boundary and then the upper boundary, but very nicely they give you that. It's 50 and it's 70. Next one is 80, 90, 95, 100, 110 and 130. And then the other side? 50, well it has to be 70. Yeah. They're the lower and the upper. And then the frequencies. What's the first frequency? 54, 45, 69, 46, 36, 58, 42. Right, so do you remember how to calculate the height, the densities?
Divided by
Yeah, it's almost that. You have to do it, we'll have to do it a little bit by steps. So the first thing we do, we should calculate the widths. So how wide is the first one?
20.
It's 20. Are they all 20 actually?
No.
No, okay. Oh no, they're not. Right, so the formula, it is the frequency divided by the width. But we also have to divide it by, what did you say? Total number. Are we told how many? 350. 350 should also be the number here when you add up all the frequencies. Yeah. So, how many decimal places will we do? 4? I doubt it. So these are all the densities, but these are the relative densities, not just the density. If you're wondering what the difference between what I did and what he did last year was, last year he didn't divide by 350, so the answers would be like this. So the only difference if you don't divide by 350, well, does anyone actually know the difference if you do or do not divide by the 350? Yeah, well, I mean, the difference is what the area represents. So, for example, if you do not divide by the 350, like here, what does the area represent? Do you know? Flip. Frequency. And then if you do divide by 350, you know, what's it called? Come on. No. Yeah, but what is that?
The area.
The area represents the area. hang on, KJ.
The portion.
The proportion, thank you. It represents proportion. So in this graph, you calculate the height as the frequency divided by the width divided by the total frequency. And in this graph, the height is just the frequency divided by the width. Now, in the past exams, that's what they wanted. But because they have a new topic, the bell curve, I'd say they want you to do it this way.
If they are in this, like coming exam, like the frequency and
they really shouldn't. I'd be disappointed if they did.
You already are disappointed, so you know.
That's true, I'm already disappointed.
You never know,
I suppose if it was exactly like this, and it shouldn't be, but if it was, then to answer your question, Fahad, maybe you want to do it this way, not divide by the total frequency. But just remember, that means your area represents a frequency instead of a proportion. Okay, anyway, for the first part, it's not even to draw anything, it's just to calculate the mean. So what else do we need to know here to get the mean? The x. So if you have numbers from 50 to 70, what do you use for the x? Like, it's not 50 and 70. You can only use one value for x. So what do you use?
50 plus 70 divided by 2.
Yeah, you use the middle, the mid value. So these are all your x's. Oops. Do you remember your formula to calculate the mean if you have a frequency? What is it?
X equals to...
Oh, here, KJ, you don't remember. You multiply the frequencies by the data and divide by the total frequency.
Yeah. Just this.
Yes, just be quiet. Right. So I'll have to write it here. So look what I'm doing. It's frequency times x plus 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 frequency times x divided by the total frequency, which is what? Do you remember? 350. So this is what I get. Too many decimal places. 89.6 is the answer. So I've done part 1 and part 2. Now part 3 is to draw the histogram. Now Excel is really ugly at drawing histograms, so I'm not even going to try and draw it in Excel. But I won't even do it. Derive can't really do it. I'll just very quickly and crudely mark out what it is here. So what are the points here? 50, 70, 80, 90. I'm not going to draw them all, okay? But I kind of need to for the next part. Alright, I will. How far do I need to go to? 95, 100, 110, 130. Alright, what's the biggest relative density? 0.026, is it? So I'll go as far as 0.03. And we'll have here 0.02 and here's 0.01. What's the first height? 0.0077. Okay, so that would be around about here. The next height is 0.0129. So that would be about to here. The next one is 0.01927. So that's nearly at the next one. Then the next one is 0.263. That would be up to here. And then 0.0206 for the next one. And then 0.0166. Now look, we have a nice bell shape here, and the last one is nearly 0. And remember here that the area is equal to a proportion. So what should the total area be? 100%. Okay. It was decided to give a certificate to those who completed the race in 76 minutes or less. Use your histogram to estimate how many runners that is. Okay, so 76 will be here. So let's get the percentage by calculating the area. So the percentage will be, what's the base of this first rectangle? 20. And the height is 0.0077. And then the base of the next rectangle?
5.
Is it 5? It's 6. It's 76 minutes. And the height? 0.0129. This is 6. 76 is here. So let's calculate that. 20 times 0.0077 plus 6 times 0.0129. That comes out at 0.2314, or in other words 23.14%. Now it said how many. So how many people ran this race? 350. So if you change this into 23% of 350 people, that would be 81 people. Because this is a bell shape, you could use your table book, but you can't because you don't know what the standard deviation is. But there is a very, listen carefully, there's a very, now what I'm doing is not the answer, but it's a way to check the answer. What did we say the average was here? We calculated earlier. It was what? 89.6. The standard deviation, now listen, this is a very, very, very rough approximation, okay? The standard deviation should be about a quarter the total width. So the smallest person is 50 and the biggest is 110. So that's 60. So a quarter of 60 is 15. Now I said that's rough, okay? So what we need to do is, our average is 89.6 and we want 76. So we have to use our Z transform. 76 minus 89.6 divided by 15. Now the reason I'm doing this is because I feel they'll change the question to include a bell curve because that's new. So this comes out at, did I type this in wrong? Are you sure it's 89.6? Yeah. Yeah, okay. Minus 0.91. Now, what do we have to look up in the table book? So, sorry, let me just mark in the value. This is 0 and this is minus 0.91. Yeah, so what were you saying, Fahad? Yeah, and then we have to do something to that though, because that will give us the area to the left.
1 minus.
Yeah, so 1 minus that. Do you have your table book? Now the answer we should get should be about 0.23, roughly. I'll be very happy if you got anything near this number. 1 minus 0.91. How good or bad is that? You have the formula book from yesterday. It's on the back page.
What do you see we should just get?
I'm not telling you.
0.35.
No, hang on. I got 18%. You got 18% as well?
18.4.
Yeah, 18%. Now,
So you won?
23.
I know, but that's amazingly good because, number one, it's not a perfect bell shape, is it? Number one. And number two, did we even calculate the standard deviation? No, we guesstimated it. So the fact that I got 18 and the true answer is 23, I consider that extremely accurate for the amount of approximation we did. Do you understand? Like, I mean, I didn't even calculate the 15. It might not even be 15. It could be 12, you know. I just estimated it because I was curious to see, you know, how close it would be to using the table value. Yeah. This is, you were asking me, maybe Fahad or Tekin, because this question didn't come up in the past, how would it be in the exam? I'm not sure, but I'm picturing something like asking you to do something like this, or something else, but we can talk about that later. Okay, so can I close this?